Hello everyone. In this video we will discuss about equilibrium constant. So we know what is an equilibrium, right? So let's say we have a reaction that is A plus B is giving rise to C plus D, but this reaction is in equilibrium, so it's double arrows, one forward and one backward. So if you want to find a equilibrium constant, so once the equilibrium is achieved, the concentrations of any of this ingredient will not change. So once the equilibrium is achieved, the concentrations of A or B or C or D will not change. It's gonna stay fixed, but the reaction will be keep going. So A is still gonna be combining with B to give you C and D. C and D is also gonna combine to give you back A and B. So the rate of forward and backward reactions will be equal. Well, what is an equilibrium constant? Equilibrium constant, we write them as Kc. Some people write as K equal, like K EQ, so that's an equilibrium constant. It doesn't matter. So the K is the equilibrium constant. So usually it's written as product concentrations divided by reactant concentrations. So the square bracket, means concentrations. So just remember this, people. So this is, so anything square bracket. So maybe I should write down here. Square bracket means concentrations. Concentrations right here. So this means the product's concentrations divided by reactant concentration. Okay, so this is not a true formula, but this is how you should approach. This is the simpler versions of equilibrium constant. So in this particular example, what do we have? What do we have our product? Our product is, we have C and D, so we got two products. So you have to factor in both of the product. And also we got two reactants, which is A and B, so which means you also have to factor in the reactant. So that's a simple equilibrium constant uh, calculation. So if I know the concentration of C, if I know the concentration of D, if I know the A and B, I can find out my equilibrium constant. So this is our equilibrium constant. So this is a simpler way to explain. So let's make it a little bit more complicated. So right now, you don't have any coefficient right before A, right? So let's say we have our previous example where we discussed this particular sulfur dioxides reacting with oxygens, right? So let's do this one. I'll do it here. Sulfur dioxide plus oxygen is in equilibrium with sulfur trioxides. Okay, so what's the balance equations? Two of them here and two of them on the product as well. So what should be our equilibrium constant? So I'm gonna start simple, then I'll give you the formula. Okay, so how many sulfur trioxide we have in our product? We have two, so you have to factor in both of the sulfur trioxides. So sulfur trioxides, so you got two products, right, in a balance equations. So instead of writing multiple times like this, you can simply write concentration of sulfur trioxide to the power 2. So that 2 is exactly same as the coefficients on your product side. Oh, sorry, I'm doing it wrong. Remember, the product is on the top. So this is the product. So our product is sulfur trioxides multiply by, not multiply, to the power by 2. And what are our reactant? We have sulfur dioxide as a reactant, SO2. How many SO2 we have? We have two SO2, so this should be raised to the power of 2. So, and then you multiply with oxygen. So that's our equilibrium constant. So you have to factor in the coefficient. So if I have to write down a formula, I would write something like this. So let's make this reactions a little bit more complicated. So let's say we have A times A. So A means the coefficients, B times B, and they are in equilibriums with C times C, and they are in equilibrium with D times D. So this time, this capital A, capital B are your reactant and products. So our equilibrium constant would be product raised to the power of their coefficient. So in this case, coefficient is small c and small d, divided by reactant, which is capital A, capital B, raised to the power of their coefficient. So this is the summary. This is what you should know. Equilibrium constants. Okay, so now let's go back, try to do a couple of things. Okay, I'm gonna do a simple reactions, A to B, and they are in equilibrium. So let's say what should be the equilibrium constant? Product concentrations divided by reactant concentrations. So in this case, what is our product? B divided by A. Okay, so let's say at equilibrium, we have 50 of A and 50 of B. So what should be our equilibrium constant? Equilibrium constant would be B divided by A. So 50 divided by 50 equals to 1. So you notice here, once the equilibrium constant is 1, that means we have equal amount of reactant and product. Well, let's have another example. Let's say at equilibrium, you have 25 of A and 75 of B. You guys get it? So once the equilibrium is achieved in a different reactions, different A and different B, and we have 25 of A and 75 of B. So can you find out the equilibrium constant for this particular example? You can pause the video here. So it's gonna be 75, which is B, divided by reactant, which is A, is 3. So what happened here? This number is greater than 1. So if our equilibrium constant is greater than 1, this means we have, which one we have more? We have more product. So when the equilibrium constant is greater than 1, we usually have more product. So this concept is extremely important. So make sure you understand the idea behind it. Well, let's say another example in another equilibrium. So we have 3 scenarios. In the third equilibrium, in a third parallel universe, we have 75 of A and 25 of B. So what should be our equilibrium constant? It's gonna be product divided by reactant. So product is 25 divided by 75. So 25, 75, so that's gonna be 1 divided by 3. So it seems like it's gonna be 0.33, 0.33, roughly around that, right? 0.33. So this number is lesser than 1. So if it is lesser than 1, you should get more reactant. More reactant. You guys get it? So again, let's recap. When the Kc is 1, so I'm gonna make a table here. So you can have 3 scenarios. Kc equals to 1, so this means it's 50-50. So this means of equal amount of reactant and product, equal amount of A and B, or we should write down reactant and product, reactant and product. If Kc is greater than 1, what should we get? We should get more product. If Kc value is less than 1, we should get more reactant. So if you get more product, that means the other one should be less reactant. If you're getting more reactant, then you should get less product. All right, so hope this explains everything. So we will use this piece of information later in the semesters.